Welcome for part 2 of Intro to Blockchain. This week we have Tom, also of Extropy, who's going to give us a fantastic presentation that I look forward to. Tom's a very smart chap who indeed took part alongside Lawrence and Extropy in the hackathon last time. And Extropy, for those that don't know, are a fantastic development agency out of Oxford, who are brilliant if you want a good blockchain development agency to do some work for you. So Tom, I'll hand over to you now. Guys, all the slides on YouTube will go up afterwards, as per usual. So if you don't catch anything on this content, you can find it there. And please use chat for questions. It's sometimes difficult for the speaker to see questions when he's presenting, so we'll probably get to questions at the end. So Tom, yeah, over to you, and thank you very much for your time this evening.
Brilliant. Thanks for the introduction, Anthony. Yeah, I look forward to this. Yeah, so we have about, we have an hour, don't we? And it's quite a lot of material to get through. So any questions, do fire them off. I believe Lawrence has said he's going to help kind of shield off any questions as I go, but I'll try and pick any up as we go as well. So yeah, the aim of today's app is how to build the app. So using a couple of blockchain and also IPFS, some terms which you might not have heard before, we'll go through in detail. As Anthony said, all the slides will be available, and all the material which I go through in this presentation will also be available. There's some links actually in the slides themselves to a Google link, so you'll be able to play along afterwards too if you like. Yeah, I work for Extropy.io, as Anthony has said. Yeah, so we're consultancy based out of Oxford, currently all working all over the world really, but we do lots of fantastic things with blockchain. Some zero knowledge proof work as well, which is always quite good fun, and some workshops which are less in person now, but yeah, still doing quite a lot of community education as we go. So yeah, please do get in touch if you have any questions or queries. I'll be happy to help guide you. Some useful prior knowledge to this presentation, some things which yeah, will help you. So Solidity, which is the language used for writing smart contracts, and Web3.js, which is the JavaScript library to interact with smart contracts via Web3. There's also Remix, MetaMask, and Ganache. These are kind of development tools. Remix being an online development environment, MetaMask being a plugin for your web browser, and Ganache, which is a desktop app which allows you to have a local blockchain so you can quickly get up and running without having to spend any money, without having to wait for block times online. And we have Node.js, which is a framework based on what's written in JavaScript, and this is what the app is written in today. Fantastic tool. There's obviously HTML, which is the markup language used for writing websites, and Express.js, which is the framework for Node.js, which allows you to create websites using all of the JavaScript plugins. There's also IPFS. This stands for Interplanetary File Storage, if no one's explained it to you before, and it's an amazing kind of decentralized file storage system. And all of these links here that are underlined take you to some resources and some tutorials if you do get hold of the slides and want to learn any more. So the outline of the presentation, I'm going to review what smart contracts are and what Solidity is using Remix. I'm going to go over some development and testing tools that I use myself and I can recommend. Going to go over writing a more complex smart contract using Remix, and then go on to building a DApp that interacts with that smart contract. Then we're going to look at how to store and retrieve data using IPFS, and go over some common problems and their solutions. And finally, some closing comments at the end, and a quick Q&A if we do have time. So to start off with, just a review of smart contracts and Solidity using Remix. So this is an online development environment that is very useful for developing smart contracts. Here we have kind of the main page that you go onto when you go to the web URL. It's a great development environment. It allows debugging and deployment of smart contracts on either your private local blockchain or on public blockchain as well. You don't necessarily need this for the workshop, but it's used. I use it regularly. It's a very commonly used tool, and yeah, I highly recommend it. So one thing to point out is any contracts that you do, any smart contracts that you write, are stored just in your browser history locally. So if you use another computer or you wipe your computer or something, then you're going to lose all of those smart contracts. So if you do write anything, develop anything in here, make sure you back it up elsewhere. So this page that we can see at the moment, we've got sort of 4 tabs on the left-hand side. One highlighted now is File Explorer, and you can see just the standard smart contracts that you get when you first go onto that web page. And in that File Explorer browser, there are the smart contracts, so all those with .sol at the end. And at the bottom, you have a terminal, which you may be familiar with. This gives you some feedback on what's going on if you do any functions. Next down, we have the compiler. This generates the ABI used to interact with the Ethereum virtual machine, whichever one that is that you'll be using. We have the Solidity version at the top here. It's important to get that correct. I'll explain why slightly later on. You have some compile options down at the bottom, so you can auto compile if you don't want to compile each time, or you can leave it off. You can have some optimization, some built-in tools that Remix offer you, and you can hide warnings if you really are feeling dangerous. And then finally, you can compile that smart contract. Next one down, we have the deploy button. And here we can choose the network environment. You can also load a compiled contract from an address. So if you've already compiled it, you know what the public address is of that smart contract. You can type that in there and load it up. As long as Remix has seen it before, then you will be able to interact with it. Finally, we have plugins, the various things which come pre-installed already. So Solidity compiler and deploy and run transactions. I also use Solidity static analysis. As it says there, checks the contract code for security vulnerabilities and bad practices. So it's just another helpful thing to make sure that you don't miss anything important. So we're going on to review of smart contracts and Solidity using Remix. So smart contracts, they are event-driven immutable function containers that run on several blockchains, including the Ethereum virtual machine. They provide immutable functions and some storage, not a huge amount, and it is expensive to store data on public blockchains. So I wouldn't recommend storing too much on there. They have some fairly well-known features such as getters and setters, where you can set values and get values from the smart contract. And you can emit states as well. So you can kind of listen into a change of a smart contract and have some code listening in for you. And when something changes in that smart contract, you can be notified of it. You can also have some protected functions. So you can have an only owner function, which restricts who can perform certain functions on that smart contract. And constructors, which can be used to initialize that state. So you can define at the start who the owner is of that smart contract. And there are things, some data structures such as arrays, where you can have some simple array manipulation on the data storage. So going through the code that you can see on the screen, at the top, we have the Solidity version definition. It's important to make sure that this aligns with the value that is in Truffle, which we will talk about later, and also Remix. So going down, we start off the contract with the contract name. So we simply name storage. Then we have a variable declaration. So we have a uint256 and it's called number. And here we have our first function. It's a function called store. It accepts one integer of type uint256 called num. It's a publicly accessible function. So that means that you can see it and you can interact with it from outside of the smart contract. And it sets a variable number to the input argument. Quite a simple function there. And then we have another publicly accessible function called retrieve. This returns the state of the number. So once you set it, then you will want to find out what that number is afterwards, and that allows you to do that. So going on to some development and testing tools. These are the sort of the ones I use and to recommend. So VS Code is an integrated development environment written by Microsoft, but it's completely free to use, and yeah, no licenses or anything like that. Very well supported in the development space, tons of plugins. You can change lots of things like colors and where things are and different features. You can have things which help you lint the code, so it aligns the code for you or highlights any errors. So tons of features there. Some of the plugins that I use, HTML preview, if you aim for 0.25 or above, and that's by, I'll give you the name of the person here because there's some plugins which are named similar things. Also prettier code formatter. This simply does things like having the indentation of your code and making sure that you have the correct semicolons and things like this. Very useful to have. Solidity, which is a formatter specifically for the Solidity language when you're writing smart contracts. Live server, which is helpful for when you want to see an update of your code when you're developing a website and you change something, you change some code, you hit save and then it can update it for you. Now we have Node.js and NPM. NPM standing for Node Package Manager. So Node.js is a JavaScript application framework and the package manager. And this is what this project is written in. It's all based off the JavaScript programming language. So there's plenty of tutorials, loads of information out there for you. It's a great language to get up and running and building apps with. And Ganache, so this is a program that is compatible on pretty much every machine you can think of, whether it be Windows, Linux, or Mac OS, or anything in between. And it allows you to have a local blockchain, which you can develop on and trial and error without losing any funds. And it's a very good tool for that. And then, of course, we have Remix, which I've gone over briefly, but that is the online development environment used for writing smart contracts, has some error handling in there, and yeah, it's a great place to start. So let's go into creating a smart contract using Remix. So the purpose of this contract that I'm going to go through is to allow someone to track unpaid invoices. So if you have something like a pub or a bar or a shop or whatever it may be, a garage, and people don't pay you up front, they might have several items that they pay for at the end. This kind of tracks what is unpaid for a particular customer or for lots of customers, and it allows you to manage that tab for each individual client. So as I said, yeah, it can record a list of unpaid items, and it will include the item name, the account name, so that will be for each individual customer, and the price of each item. We'll also be able to get to the list, so we'll be able to see what unpaid items there are. We'll be able to clear that list, so we'll be able to remove all the items from that list. We'll be able to search through that list and remove a specific item. And the file, if you download the files at the end of this presentation, the file is customertab.sol, and that's the file that I'm going to be going through and explaining. So this is the headers of customertab.sol. First off, we have the contract license. This has been introduced in Solidity 0.6.8, and it's just identifier so developers can specify the license the contract uses. If you're using something like OpenZeppelin contracts, then they use the MIT license, for example. So in this particular one, we have the Solidity version here pointed out of 0.7.0. We have the ABI encoder that we're going to use. So the standard ABI coder does not allow arrays of dynamic types, structs, or nested variables between the Solidity contacts and the contract, and the DApp. So the ABI v2 encoder allows structs, nested, and dynamic variables to be passed into functions, and also returned from functions and emitted by events. And then at the bottom, we have the contract name. So we're calling it customer tab. So going down that file, you will then see a constructor statement. And it's used here to enable access control over some functions. It's called only once when the contract is first deployed, and so it can't be changed. That owner is always the message.sender, who is the person who deploys that contract. We then have a variable declaration for the contract owner. So it's the data type is address, and we're calling it owner. And we've got a modifier, and this can check the state of a variable and provide some control over the contract functions. And we'll see this in action later on. So it can basically restrict who can call a particular function. So going down that file, we then have a definition of an array to be stored. This is a struct. It can be comprised of data of multiple types. So we're calling it sale. This is the name of our struct. And yeah, we also have a mapping at the bottom. So this function allows a lookup of a particular customer address to a data type of type sale, which is defined above. And in that struct, we have, so it's 3 data types in there, 3 variables in there. We have time of sale, we have item ID, and we have price. So those would be returned when we call on this function. Now we have a couple of events. Now events, they allow external programs to listen in and be push notified of a change. You'll see a keyword in there, an additional keyword called indexed. This is required to filter events being received by another app. If you don't use that keyword for a variable, then you won't be able to filter on that data type. So at the top, we have one item sold, and it's an event to notify of an item being added to a tab. And underneath, we have another event called item paid, and that's to notify of an item being removed from a tab. So now we're going to go on to how to store information. So this is when we need to add something onto a customer tab, and we have 4 steps to this for this particular function. So first off, right at the top, we have the function name and the inputs. Then we are going to declare that it's an external function, so it's visible for people to interact with outside of the smart contract. Then we have these 4 steps. So the first step is we're going to grab the customer tab. So this is using that mapping that we just spoke about. So we're going to generate a timestamp. So we're going to generate a timestamp, which is based on the block time. This means that you don't need to put in the timestamp when you're calling this function. It will generate it on the fly, so it makes the contract call slightly easier. And we're going to add an item to the tab. So that sales.push line, we're going to push an item with that particular time that we've just generated, with a particular item ID and a particular price. And these are all the inputs to that function. And we're going to push that onto that struct, that sales struct that we've spoken about before. And then finally, we're going to emit an event under item sold with the time, with the item ID, with the price, and with the customer pub key. So whose tab it's going to be going under. And this is just a quick reminder of that event, item sold. So there are those 4 parameters that are going to be emitted along with that event. Now, if we wanted to retrieve the tab for a customer, so if we wanted to find out how many items are on a particular customer's tab, then we have this quite simple function here. So we have the function name and the input being just a customer pub key. It's also external, as you can see there, so it's available to be interacted with. And we're going to return something this time. So we're going to return an array, a sale array. So that sale refers to the struct that was defined earlier. And we're going to return a mapping for an address. So we're going to use that mapping function with the customer pub key, and we're going to return that to whatever has called this particular function. Now, say for example, someone has paid off all of their tab and you want to clear it, or someone's done a good deed and you want to remove all the things they owe, then we have this function here called reset tab. You can't simply delete an array in Solidity either. This is one thing to point out. So it's a bit roundabout to delete items in an array, and this is how you do it. And it is quite computationally expensive for a large array. So you have the function name at the top, reset tab. You have the input, which is the customer pub key. So this is how you reference which tab it is that you want to clear. It's external, so it's available to be interacted with externally. And then we have the only owner keyword. So this was defined when the contract was first put onto the blockchain, and it means that only the owner can call this function. Then we have a few steps here. So first off, we're going to grab the customer's tab. So we're going to look up the tab for that particular customer and keep it in here in a variable called sales. We're going to check if there is anything on that tab. So we're going to obviously only loop through it if there is anything that exists. Then we're going to loop through that tab, and we're going to remove every item that we come across. And finally, we're going to emit an event called item paid, and we're going to emit, again, those 4 parameters. So the time, Unix time, and that is just generated on the fly, as you can see it there, block.timestamp, The item ID is just the star in a string, so it's everything, it's all. The price just set to 0, but that can be set to anything. And also the customer pub key, so whose tab it is that we've just cleared. We're also going to emit that piece of information. So if we wanted to remove one item from the tab, instead of removing everything, we would want to search through, find the item, and then delete it from that array and save that array back. So this removes a specific item from an array. So first off, we have the function name at the top here with the inputs. So we have the customer pub key, that's whose tab we want to find, and also the item ID. Now we have a few steps here that we're going to run through here. Also worth noticing that this is an external function again, and only owner. So it's only the owner of the contract that is able to interact with this particular function. So first off, we're going to look up a customer tab for that customer pub key, and we're going to keep it in memory here. Then we're going to loop through all of the items in that tab. For each item in that list, we're going to store that temporarily in memory. And this allows us then to do the next function, which is checking it for a match. It's not a direct comparison. So Solidity has some quirks, and this is one of them. You don't have a string compare function unless you want to include an external library. So this is a way to get around that without having any other dependencies. And cat256 is just a hashing. So you're comparing the two hashes of two variables rather than comparing the raw string. If there is indeed a match, then what we're going to do is notify subscribers that something has been taken out, or is going to be taken out from that array. We're going to reorder the array if the size is greater than 1. We're going to remove the matching item, and we're going to stop that loop. So we're not going to want to carry on looping around once we found that item and taken it out of that tab. So it's a bit of a whirlwind tour of the contract, but a quick summary of what we've just gone over. So we have the constructor used to set the contract owner. We have the definition of array to be stored, which was struct. We have a mapping of a customer ID to their tab, so that allowed us to look up what tab existed for each customer pub key. We also had a couple of events being emitted. So emit event when an item is added or removed, or a tab is completely cleared. We're also able to add an item against the public key and retrieve a list of unpaid items. Finally, or maybe not finally, we can reset a customer's tab, and we can remove an item from a customer's tab. So those were all of the different functions that we went over in that smart contract. So next, we're going to utilize that smart contract and build the app around it. So we're going to build the app that interacts with that smart contract. So we're going to be setting up the project folder. As I said, all of these files are available, but I will go through them step by step. And there's two different types of project files available. There is the whole project file where you can simply npm install and run it, or there are the core files if you wanted to have a bit more of a feel of what's going on. So yeah, you can take your pick. So we're going to set up the project folder, and that includes installing Node.js and any dependencies. Then we're going to configure truffle, and truffle is something that we've not spoken about before yet, but this allows you to compile and migrate smart contracts. Then we're going to compile and migrate the smart contracts. Then we're going to write some functions for interacting with the smart contract. So these reflect those functions that we've gone through for the smart contract already. So we're going to be able to add an item, we're going to get the tab, reset the tab, remove an item, and watch. So this is for the events when you can watch when there's something happening. Then we're going to build a front end with Express.js, build a simple website so you can interact with this app. The files are available here, as I've said. So first off, you need to set up your project folder. So you're going to initialize your Node.js environment. So this is how you create a project folder and initialize a Node.js project. The npm init Y simply means yes to all defaults, so it just quickly sets it up for you. So you need to install some dependencies. These do take some time to install, so don't worry if it takes a few minutes to go through them all. First off, along that line, so we have npm and install, which are just the key command words. Then we have Express, which is the browser framework for Node.js. We have body parser, which is required to process requests from the front end to the application. Then we have Truffle, and this allows us to compile smart contracts, it links and deploys smart contracts to the blockchain, and it does some binary management as well. So it converts your Solidity code into sort of machine code. Then we have Web3. These are the methods to interact with the smart contract. We have IPFS, and this is a library for interacting with the IPFS network. And finally, we have it-all, which groups IPFS data from a single CID. A couple of words you may not be familiar with, so I apologize, we'll go through them. And all it does is it grabs all of that data into a single object. So it makes it quite easy to get some data from the IPFS network and have it in one variable. So next up, we need to initialize the Truffle project. So in your project directory, where you've typed in npm init and npm install commands rather, you then need to write Truffle init. And you'll need to modify Truffle config. So once you've written Truffle init, there will be some additional folders and files that get generated for you. One of them is truffleconfig.js, and in there at around line 45 or so, you will need to change the or uncomment some lines basically, and replicate what you can see on the slide here. This is so that your Truffle software can interact with Ganache, with your local blockchain. And you'll also need to change the version of Solidity in that same file, truffleconfig.js, so it matches the smart contract, and that's around should be line 88. And this should now be what your project directory tree looks like, minus a couple of files. So to add them in, these are the files that are included with the presentation. So you'll need to copy app.js into the top level. You need to copy customer tab.sol. So this is the smart contract that we've run through. You need to put it in the folder contracts. You need to copy deploy contracts into the migrations folder, and copy the whole folder and all of its contents. The folder's called source. Copy that into the top level, and copy the views in the folder as well, and all of the contents into the top level. And that has the index.html, which is it's just the front end page that you see when you go onto the website and interact with the app. So going on to compile and migrating smart contract. Ganache makes it very easy to get up and running with a local blockchain. Simply open the application and you're basically up and running. So here's a link to download it. As I said, it is very compatible with lots of different operating systems, so it should run for you. Once you've downloaded and installed it, you can hit quick start, and this will open up the window that you can see in the bottom left of the slide. The main window, it shows a list of funded accounts, and these are all available for development. The first account that you can see listed is the account used by Truffle for migrating contracts. Therefore, it's the first account, and it is the owner account. So when you migrate and deploy the smart contract, this is the owner of the smart contract. So the network settings for Truffle, which are shown at the top, these should match what's in Truffle config. To get the private key, which you'll need later on, you can click this key button and you get this window popping up, and that's that private key listed there. So that means you can act on behalf of that account. So compiling the smart contract, from the top level, from the parent directory, you need to type in Truffle compile and hit enter. And that will do a few things, but mainly it will well, we'll just compile the smart contract, actually, this one. So we'll compile a smart contract and put it into the contract folder for you. And then, yes, sorry, this is the more complex step. So truffle migrate, this is where it actually deploys it onto the blockchain for you. So when you type this in, you will get some feed out, some readout on your console, and you will see one piece of information labeled contract address. You'll need to copy this into the node project. This will allow you to interact with this particular smart contract. So jumping on to actually developing the app in order to interact with the smart contract. And this is the content, some of the contents of the file web3funds.js, and I'll quickly run through what each of the lines does. So here we can see the JavaScript file header section. So we're outlining some dependencies, one of which is the Web3 dependency, and also we're pointing the Web3 dependency to our Ganache local blockchain. Then we need to reference our smart contract. So we're going to point it to the JSON file that was generated when the contract was, when it was compiled, I think, not migrated. So when it was compiled, that customer tab.json is generated, and you need to point to that. The address from the, when you did deploy the smart contract, you need to copy that into here, and that just points the code to that smart contract on the blockchain. Then you create a contract instance using that information. And there's, in addition, this timestamp parser, which is kind of a bit of fun, really, but it means that you can convert a Unix timestamp, which is pretty hard to know what time it's talking of, to a human readable time. So it's an additional dependency included in the project for you. So going on to sort of further down in the same file, so still in web3funds.js. Now we have to copy some more information in. So at the top of Ganache, you had the owner address, owner account. You need to copy the public key into here, and the private key, of course. Then you need to add that account to the local wallet. So you add the owner wallet to the Web3 instance, and that means that you can start to act on behalf of that account. And at the bottom, we have, you're setting a limit for gas. Gas is used to power smart contracts. You can think of it as the same as gas in a car, if you're American, or petrol in a car, or diesel. And it's something that is burned, and it allows something to happen, and you can't recover it. So going further down that file, we have a first function, which is called add item. So it's an asynchronous function, which means that it doesn't happen instantaneously, that there's going to be some time delay from calling the function to getting the response. The function is called add item, and it accepts 3 parameters there. So customer pub key, item ID, and price. We then have some code within an await bracket, or await section. The await is linking up with the async part. So you're defining that the function is an asynchronous function, and then you're saying that this next bit of code you need to wait for. So you're submitting those parameters that you called the function with to the smart contract function add sale for customer. When you get a receipt from the blockchain, then the response from that will be put into a JSON object, and that JSON object will be returned to the application to confirm that that call has been successful. Next up in that same file again, we have another function. It's another asynchronous function called remove item, and it accepts 2 parameters. So we have another await section called item, which is calling item paid by customer, and this is again another smart contract function. Once there's been a a receipt from the blockchain, then the receipt is put into a JSON object, and the JSON object is returned to confirm that that was an OK function to call. It's worth pointing out that there's that variable at the top called response, which is defined at the top, and it's defined outside of the try-catch block. And if you don't define it outside, then you will fail to get the value back. So yeah, just worth pointing out that you have to define that variable outside of the try-catch statement, and then you can populate it within the try-catch statement and return. Next up, we have a get tab, and this simply returns the whole tab for a particular customer pub key. It's async function again, because it takes a bit of time to carry out, and it accepts one parameter called customer pub key. We're going to await for this particular method, and when we get the response, which is the customer tab, then we put that into the variable response that we've already defined. And we're going to return that variable to the application. Now, if we wanted to reset the tab, this is the contract call for that. So it's another asynchronous function, and it accepts one parameter, customer pub key. There is no return on this, so it just calls that particular function. Now, if we did want to track something, so if you wanted to be notified of something happening, then this function performs that. So it's a function called track added, and it accepts one parameter, customer pub, which is the customer pub key. So in this instance, when an item sold event is emitted and the parameter customer pub key matches, then that returned item is put into the event my field, and it is simply put onto the console. So instead of returning it onto the browser interface, it will put it onto the console for you whenever something happens onto that smart contract. And this, instead of tracking just one of those events, this will track everything that happens. So it's called track all. It does accept one parameter. However, there is a quirk, I would say, with Web3.js, where you can't filter on all events in this case. So if you did want to filter out just that customer pub key, then you would have to generate or create your own filter function. So it reacts to all events from the smart contract. And depending on whether the event is item sold or item added, then it will set that variable my field to added or removed, put that my field into that variable, and it will put that onto the console. So you'll be notified of what's been sold or what's been added to a particular customer's tab. Now, to interact with all of this, we could use a command line. It's a perfectly valid way to do it. However, it's nice to have some sort of interface. So I'm going to go over quite quickly how to build a front end using Express. And all of these files, again, are included in this project if you did want to pick it up and run. So you can modify them as you wish. So it's a very simple interface using, again, it is Node.js and it is Express.js, which is a framework for Node.js, or for JavaScript rather. And yeah, just allow some interaction with the functions that we've just gone over. So in general, Node.js Express, it's not the most obvious thing to look at when you first start playing around with it. So it's made up of 3 file types. You have HTML files. These kind of generate the page layout and the interaction, as you can see in that image on the right-hand side. You have JavaScript files that provide the logic. So as an example, the slides we've just gone over, this is JavaScript file, and this provides kind of the logic of the application. And CSS files, which are used on every website on the internet, and they just add some page styling. And this is, so it's not the most obvious thing to get your head around when first using Express, but I've tried to outline how Express works, because it can be tricky when debugging, when trying to figure out what's going on or what's gone wrong, where it's gone wrong. So these are the steps involved in one particular function call. So you start off, sorry, the columns are the different files. So you start off on app.js, and that routes the browser to index.html. That presents you your website, the front end, and it waits for a user input, so waits for a button click. When a button is pressed, then it routes that information to a file called Ajax web3.js. I won't have time to go over what that file does in detail, I'm afraid, but Ajax is a JavaScript function, it's a feature, and it allows you to update a website in real time without refreshing the web page. So it's very good for updating fields or form fields without refreshing the whole web page. So the button is pressed and it goes via Ajax web3.js, which then routes that input back to app.js. This then figures out where it should be going in our functions that we've made, and it routes the input all the way over there to web3funds.js. This is the actual core of the app. This is the contract calls. This is where all of the logic is that we've gone over so far. So it handles that function call. When it gets a response from the blockchain, from the smart contract, then it passes that back to app.js, and it routes that data back to Ajax web3.js. This then, in real time, without refreshing the web page, modifies the page elements. And finally, the HTML is updated on the page for you. So I hope you can follow that. I've tried to make it quite straightforward, but as you can see, it does jump around a bit. So this is kind of the front end that you will see when you run the app. Sorry for those additional arrows there, they shouldn't be there quite yet. But when you run the program, you'll need to run it using the command node app.js. You do that from the parent directory. If everything's okay, you'll get a readout on your terminal, Web3 funds loaded, site available here. You can click on that link and it will take you to this web page. On this web page, then you can start playing around. So you can start putting in some values. Customer pub key, you will have to put in a valid pub key, so you can take it from Ganesh, take any of those pub keys, put an item in there. So I'm buying a submarine for 42. And then you can add that item to the tab and you will get a response from your blockchain in the form of a transaction hash, which is then printed out on screen. All of this happens without refreshing the web page, as I said, and that's the Ajax side of things. And this is the contract call. So once you add some information, you can add it to a tab. You can add as much stuff as you like, and it will just continually add on to that customer's tab. You can change the customer pub key, add it to another tab. So you have now the ability of tracking a list of items for multiple people. You can then also remove an item from the tab. So if you type in submarine and hit remove item from tab, you'll be able to remove that off. Or if you add a bunch of items and you want to see what's there, you can select list items on tab, and it will find for that customer pub key what items are on the tab and list out on screen for you. So that is the hash, the transaction hash returned by the blockchain, just to confirm that your contract call was a success. So on the website, when you're doing web development generally, most web browsers now have quite a nice set of tools built into them. You can hit F12 on your browser, and you can bring up a console. This allows you to have some additional debugging tools, and if everything goes okay when you're running this app, you will get a printout OK, just a simple OK to let you know that everything's okay, that nothing's gone wrong. If there's an issue that the browser detects, then it will print it out here, and that helps you kind of pinpoint where the problem is. So yeah, you can hit F12 on any website, in fact, select console, and you will get this additional information. So when you're actually interacting with the smart contract, you will get those events emitted. So the events, which are kind of real-time flags or push notifications, This is the sort of thing that you will see in your Visual Studio Code terminal window if you are using Visual Studio Code. And it will tell you whenever anyone has interacted with that smart contract, it will give you some information about it in real time. So you can then start to plug into that and do some response to that if you like. So you can build up on that basically. So a summary over building the app. So we have now a Node.js project with an Express front end. We have an interface that allows querying, writing, and removing data from a smart contract. And we have an interface that displays relevant data. Apologize again, I didn't go into Ajax, basically because of time, but there'll be my details at the end of the presentation. So feel free to send me a message if it's a bit confusing or if you need some pointers. Now we're going to run through how to store data on IPFS. So storing data on a blockchain is possible, but it's quite expensive. So when I wrote this presentation a couple of months ago, or a couple of weeks ago, I've modified it now, but I didn't double check the price. So 1 gigabyte on Ethereum would cost you $16.5 million to store. And that was at a price of $470 per ETH. So it's not cheap. So there has to be something else, some cheaper method. And a decentralized method would be nice, and IPFS supplies this for you. So it stands for Interplanetary File System, and it's a network of computers that stores data in a decentralized fashion. Completely free to use, unless you want to start to hire other people to store your data for you. It's still very, very cheap. The additional libraries that you need to interact with IPFS are JS IPFS and ITOR. So those were the two at the end of the install command at the start of the presentation. So a couple of words about IPFS, decentralized storage. You can store it locally, so you can play around online, perfectly valid to do that. Or you can store it online. You can have a bunch of computers or a bunch of servers which you interact with and store data online for you. You can have a single node, or you can have a cluster. So you can have a group of computers communicating together. If you wanted, for example, to have multiple redundant copies of a particular file, then you might want to have a cluster of computers all communicating together to ensure you have at least 2 or at least 3 versions of the same file at any one time. You can also pin data. So IPFS by default, it has a limit of, I think it's 10 gigabytes of storage on your local machine. Once that limit has been exceeded, then it would simply delete the oldest file. If you wanted a file to stay on your computer and not be deleted, then you can pin it, and that just means that it will not be deleted when it gets to the bottom of the list. Filecoin is the extension to IPFS, still built by Protocol Labs, which are the guys that write IPFS. And this is the next stage on. So this is their, I guess it's their Amazon killer in a way, Amazon AWS storage. They're now trying to decentralize file storage. They have some really fantastic proofs in there. Yeah, it's fairly complex the way that they prove that your data is being stored, and it's far cheaper, according to what we know so far, to store data on there. It's going from something like $60 per year to $6 per year to store the same amount of data, to store a gig of data over a year using Filecoin. So to have these functions, we need to have a couple of additional files in our project. These files are Ajax IPFS and IPFS funds. So to have those in your folder, just copy those into your source folder. IPFS funds is the kind of the core of how to interact with IPFS. So I'll quickly run through what each of the lines of the code does. So we have the file dependencies. These are the two additional dependencies that we installed. So we have IPFS, which is the library for interacting with the IPFS network, and ITOR, which it groups that data for you. Now we have another asynchronous function called IPFS init, and that simply initializes an IPFS node. That that now means that you have an IPFS node running in your browser. Once that node is initialized, it's returned to the application so it can start to interact with it. The next function we have is IPFS add. So if we want to add something to our IPFS node, it's another asynchronous function. We pass to it our node, which we've just generated, we've just initialized, and also some data. So what we want to do is we want to add that data using our node, and we return a confirmation that that's happened. Another function is maybe we want to get some data from the IPFS network. So we have an asynchronous function called IPFS get, and that gets data from IPFS. We pass it the nodes that we've generated and the CID. Now, this is a content ID, I think that means. Apologies. And this is a unique ID. It's calculated by hashing a file, and it's a unique identifier for every file. So it's a very reliable way of addressing files and collecting files. If you know the CID of a file, then you can be sure that the contents are what you expect. So this is where that it-all dependency comes into play. So what we're going to do is initialize a variable called data. We're going to take the CID for the file that we want, kind of going from right to left here. We're going to catenate, which is concatenate data from that CID. And using that all dependency, we're going to put that data into our variable called data. Finally, we're going to take that data and we're going to return it to the calling function in a string format so we can read what we put in. So underneath the functions that we've gone through before for Web3, there's an IPFS section. And you can start playing around with it and adding data to IPFS. So once you start your app again, you'll see some additional readouts here from IPFS. This is simply saying that your IPFS node is up and running and it's listening out for interaction. So you can write some information in there, write some data, and you can add it to IPFS. And you will get the output at the bottom, which is the CID. If you typed in hello world with those letters capitalized and an exclamation mark, you would get the same CID back because it's exactly the same data that you're putting onto IPFS. So a quick summary is that we've been able to add and view data to IPFS using the Express app. So I'm very wary of time. We have a couple of minutes left. This is a very wordy slide, so I'm not going to go through it, but there are a bunch of issues which I've come across, so certain debugging things. So if you have any issues, it's worth quickly running through these. These are some first things to try. It explains why they've happened. Maybe you're not getting values back or variables back. And these are some things you can try to resolve them. So some closing comments, topics included that we've covered: Truffle, Ganache, Web3, VS Code, the development environment, Node.js, Solidity, Remix, IPFS, building the app, and debugging for about 10 seconds, and resolving issues. So some further work, you could have some additional error handling. Maybe if there's a non-integer in the price, something like this. You could add some delays to stop spamming the network because that can cause it to fall over. You could allow the contract to receive multiple items in one transaction to increase the efficiency. You could password protect features to avoid somebody doing some things which you're not allowed to. You could have some real-time updates using another extension called Socket.io. And you could integrate Web3 and Bitcoin Lightning perhaps as well. So you can have some payments alongside it. And thanks very much. So please do visit our website, xtrp.foundation, for some other tutorials if you wanted to see some more. And yeah, thank you very much for your time. Anthony, I'll hand back to you.
Thank you very much, Tom. Any questions for Tom? I know a lot of you might tend to use Discord, but we'll do that. Oh, there's another one. There is a question. Can the data on IPFS be video?
It can be anything at all, yes. So it could be a video, it could be a photo, a song, absolutely. We're using a string here just because it's easy to add and remove on screen, that's all.
Okay, great. Any other questions for Tom? Please throw more light on the SPDX license, how to use it in Solidity and why.
So the license, if you are writing a smart contract, you need to license, or you need to state the license for it. Generally, you can say unlicensed if you're doing some development work. This is just a new feature to allow you to use that new ABI encoder. Yeah, I don't know too much about it, so that's all I can offer, I'm afraid.
Okay. Any other questions? Awkward moment of silence. Okay, Tom, thank you so much for your time. For everyone else, I will please, I'll put the slides up, I'll put the YouTube up. Please send me a message if there's any questions for Tom. But Tom, thank you very much. And Lawrence, I know you're here as well. Thank you very much for last week as well. I know that everyone will enjoy this content, particularly on the YouTube.